Hi, I'm Blake Hale, and this is my critical design review for Engineering 100. So our problem definition was that we need a durable wheel system and a redesigned chassis that can withstand the different terrains of Mars. Our design requirements is that the rover cannot be over 3 pounds. The tire must be designed from at least 2 different materials. The chassis must be totally redesigned or just modified, but not 3D printed using the resources from the measle. The wheels attached must fit entirely within a square box with all 4 wheels touching the floor in that box. Any completed design must be tested successfully 2 times, and a mean average time must be calculated. The rover must be easy to disassemble and reusable at the end of this term. What our group originally planned to do was 3D printing the wheels and then creating a suspension system on our chassis. So my conceptual design was, after we broke up into individuals, I decided to steer away from what my group was doing so that I can make it more unique. I went with a design that has 2 cylinder wheels that are both the length of the car and spaced to almost where wheels would normally be. This design I had in mind would allow for a larger surface contact area, which and then in return would allow for the wheels to last longer due to the fact that specific parts of the cylinders would not wear down as fast as others, which in the long term would allow for the cylinder wheels to last longer. In my circuit design, I had used just a basic 2 motor system with a switch being the main component that turns it on and off. Originally, if I had the circuit and my group, we were gonna integrate a variable suspension system into it, which we would have had to have put an additional at least 2 motors on the system, which would allow us to rise and lower the suspension of the car. My Arduino sketch, the major aspects of it really was that so the major blocks of the code was just basically to go forward and to stop after a specific amount of time. That was obviously changed from our original anticipated design, as we were going to make in the code, obviously, a suspension system, which we were going to use to a ping sensor, which would sense the terrain in front of the rover, which we would have coded in to where the front suspension or the back suspension would rise, and then once we made it over that terrain, then it would lower it back down to the desired height, lowering the center of gravity and making it a more stable car. My experimental design results, the experiment I did with my rover actually turned out pretty well. I found that the cylinder wheels do allow for more surface contact, more traction, but they also, when going up an incline, they're slower. So after doing the experiment, I realized that for this design to be more realistic, there would have to be some type of gear system in play, which would take a lot of the stress off of the motors. So my project meets the design requirements and the aspect that I made 2 really differently sophisticated wheels. They were obviously in the shape of cylinders, something that isn't very common, at least I don't think is very common in retrospect to a Rover. Also, the body, the chassis of the Rover, I made it more aerodynamic by adding a point to the front of it. This will allow for less resistance against the car, which then in return takes less strain off the motors that are spinning the wheels, which in reality, that's the ultimate goal, to reduce that stress as much as possible, especially whenever it's such a big wheel that the motor has to turn for the Rover to move, which really is why a gearbox would be a huge play into the creation of the idea for the Rover that I have. All right, thank you.